So Mr. Didier Rigal is part of the IRT, so which is like a research center linked to Saint-Exupéry in Toulouse. I will let you to introduce yourself.
Thank you.
And then the floor is yours. Thank you.
Thank you very much for your introduction, and thank you for hosting us today. I do represent the Institute of Research and Technology of Saint-Exupéry, an institute which is focusing on aeronautics, space, and critical systems. And today I will briefly introduce to you what are the competencies that we are developing, and in which way we do transversely address the subjects of the space industry, of the aeronautics, and of the transport, and what kind of synergies can be settled between the different domains. A brief overview of my parcours, which is to say that I'm a pure aerospace man, having spent my entire life into Airbus, Telespazio, and then Thales Alenia Space, and I joined Institute of Research and Technology this summer, quite recently, to animate the development, the business development of those institutes, and the development of the platforms that are used in the diverse domain of competencies. Next slide, please. So in terms of footprint, ERT are numerous in France. We have about 16 ERT covering various domains. Of course, we are each of them specialize in different topics. We, ERT Saint-Exupéry, have different interactions with the other one in the domain of telecommunication, in the domain of artificial intelligence, in the domain of materials mainly. And we do develop joint projects transversely, particularly in the domain of artificial intelligence, where we have common and transverse projects, and also material. Next slide, please. So we do cover a wide range of activities. One of the particularities of the ERTs are that they are focusing on project development. And as you might know, we do promote projects where we can provide co-financing from the PIA, Plan Industriel d'Avenir, and by developing those projects, we also have another particularity, which is to associate the academics world with the industry. And as you see in our people shaping, we have about 376 people working within the DRT Saint-Exupéry, among which about 170 are from the industry. And this is a richness that we do develop, which is very specific to this mechanism of development, and providing a lot of transversalities between the industry, the way of working and developing the program and the engineering globally in this domain with the academic components and the fundamental research. So this is really something on which we do capitalize. We are yielding quite a high number of PhDs, publications also. You see about 172 publications since the ERT was created. And an activity which is today in the domain, in the range of 40 million euro, I would say. This year it will be almost 40 million euro. And in terms of sites, we have 4 sites in France, one in Sophia Antipolis, one in Montpellier, one in Toulouse, the B612, the B612. If you don't know the place, it's a big building close to La Beige, where we have about 10,000 square meters of platforms, and also quite a big site in Bordeaux. And last but not least, we have also a site in Quebec now, in which we do develop artificial intelligence. Next slide, please. So in the domain for which we are sharing today, transfer vision of contributions through different sectors, we have an internal program that we develop which purpose is really to animate and develop the transversalities of technologies. and particularly to synchronize different sectors in the mobility domain, and with the preoccupation of bringing green technologies, I would say, particularly in the domain of aerospace, where electricity was not at the core of the propulsion, for instance, but also to accelerate the research on a transverse way, for instance, in the domain of artificial intelligence. Of course, we have dealt with the fundamentals in the mathematics domain, but also we do implement program for applications in the critical systems for aerospace, for the space industry, but also for the train, for the automotive system, even in the domain of healthcare and robotics. We have activities in that domain. And we do develop and optimize platforms and competencies to enlarge the overlap and bring a broad picture transversely. Next slide, please. So in terms of footprint, we do have 12 competence centers that are distributed on 4 technological axes. What we do call green technologies refers to everything linked to the high voltage energy, the reliability on the energy domain, and also the density. So of course we have that kind of applications, a lot of subjects related to the management of the different voltages and the critical issues that this is yielding into a plane, into a train, into an automotive system. We do address subjects like transfer from SiC components, ground gap components, to GaN components, nitride of gallium components, to provide a more efficient system for the conversion of energy. In the advanced manufacturing domain, we do have 3 competence centers in the metallic materials, composite materials, and surfaces and assemblies methodologies and processing, which is also quite intensively used in the aircraft, but not only, intensively also in other domains, particularly bringing new functionalities to the material, incorporating sensors, incorporating different means of communications, the possibilities to integrate antennas into the material itself. It's a domain in which we have a lot of transversality. In the smart technologies, of course, covers everything related to artificial intelligence for critical systems, a lot of things in the domain of artificial intelligence for embarkability. So what is the predictability and the capacity to trust artificial intelligence. Also a lot of things in the domain of machine learning, reinforced learning, and autonomy and connectivity. And last but not least, the method and tools for development of complex systems is an axis in which we do develop system engineering methodologies for multiple discipline optimization, and particularly for critical embedded systems. Next slide, please. So I will fly over some examples that correspond to the equipments and the laboratories that we have in the different domain to illustrate the transversality. In the domain of high voltage energy, as we see here we have, of course, different laboratory to test and develop different material, optimizing the partial discharge phenomena, and it can be used, of course, for the different network and of transport of energy into a plane, into a train, into an automotive system. But it is also usable for the space industry. In that case, it's typically kind of modelization capability of the arc that came from the transport sector and that is now valorized into the space domain. And also a lot of things into the aging domain. Analysis of aging of the different materials submitted to different partial discharges into different environments. Next slide, please. In the domain of reliability, I was saying before that we perform a lot of things in the GaN domain. The nitride of gallium technologies are more and more used and usable into the energy conversion systems. Of course, you know that there is a problem with SiC components availability currently, so it's important to find alternatives. And more broadly, it's also something which is bringing flexibility and competitiveness into all the domains. So we have a lot of projects in that domain to develop not only testing benchmark, but also the capacity to anticipate what are the reliability and the performances of those systems into different environments from space to ground. Next slide, please. On the metallic material and processes and assemblies domain, the ERT is quite well equipped with different processing units for different material, and the composite particularly. You see it on the picture here. Currently, there was a lot of work conducted in the domain of functionalization, so bringing new features to the materials to serve the applications with specific functionalities, like the antenna development embedded into the material, for instance. And this is applicable to transport, to plane, and also to space, I can tell you. So it's quite an active domain in which ERT is playing a key role. Next slide, please. Artificial intelligence domain is one of the foundation layer, I would say, of ERT Saint-Exupéry. The first topic and the first focus was on the explainable, certifiable, frugal learning. So the capacity of artificial intelligence to be used into an embarked and critical system. So we don't allocate the decision to pigeons, as I said this morning, but in some cases you have to know what is behind the neural network that you are using, and in which way it can potentially provide answers that are not necessary into the domain of flight of the system. So we have done a lot of things with low TRL levels on the mathematical part of this to explain the way the neural network are working, the way they are developed, the way they are maintained, and they do evolve. And we continue to work on this domain quite intensively in collaboration with ANITI, and we have also a lot of collaboration with Systemix and Saclay ERT also in the domain with Jules Verne also, and now in Quebec. In Quebec, we have a small team that is that was settled just before the COVID. So, of course, during the COVID period, it was not very active in terms of development, but now it is raising up again, and it's a place where there are amazing competencies and partnership to be developed jointly with about 70 people that we have in Toulouse working in that domain. Important to say also that artificial intelligence is not only for artificial intelligence, it's also serving the needs of the energy transport assessment or the material design. So we have now since several months, I would say, developed a lot of more transversality, I would say, between the different technological domains by themselves. To have the capacity to use also those methodologies for the design phases of the systems. And this is bringing us on the next slide to the last domain of competencies, which is the multiple discipline optimization. Domain which is not very much developed in France, but which is now starting to take more and more importance, because it's core for competitivity, and we have developed into ERT an amazing processing suite which is called GEMCO in Python, which is allowing to address any engineering issue with the capacity to optimize the design with those MDA methodologies. And I can tell you that we have applied those tools for very different applications, like, of course, concept of material, but also a resolution of a complex system, like a wing system for an aeroplane, or a specific design for a model of climate, And it's amazing the capacity of those methodologies to solve very complex equations. I think I do cover the entire scope here. Of course, I cannot enter into detailed explanation of the reusability, but I hope that I have exposed to you all the potentials and synergies that we can bring along with those competencies, 12 competencies center and 4 axes of technology. And you are all invited to address ERT, Saint-Exupéry, in Toulouse or in the other places, to work jointly with you, develop projects with you, using or not using the PAA co-funding. We have the capacity to address your needs with solutions. Thank you for your time.
Well, thank you again, Didier, for your nice presentation from the IRT. And well, maybe a quick question is, like I've heard often,
Please.
that the aircraft and the aerospace industry is much way in advance compared to the railway industry. Is that really true?
Not in all domains, I wouldn't say so, but we are. It is more advanced. Some specific critical issues related to the aerospace. For instance, in the material domain, there is, of course, a weight equation to be solved for a plane that maybe you don't have immediately to solve for a train or an automotive system. But the technologies that we are developing are reusable fully, and I'm myself, coming from the aerospace industry, amazed with the number of transversalities that I do discover within ERT and the technologies that we have developed.
Well, thank you very much.